Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today I want to talk about how you can use a derivative to check the limit definition. All right, so what I mean by limit definition is this. So if I have, and let me change my marker here, if I have the limit as h approaches 0 of f of x plus h minus f of x all over h, sounds kind of like the quadratic formula, then that's equal to, that's the same thing as just taking the derivative, which means d dx, which means take the derivative of that thing, and that's the thing. So that's the limit definition. So this video is going to be applicable to you if you are taking calculus or pre-calc or even algebra 2, because you start talking about this way back in algebra 2. You just might not have realized it because you didn't know, what the whole f of x plus h thing was for until later on. So if you're in algebra 2, this portion right here of the video I'm going to do is going to be helpful for you. So this is algebra 2, right? And then the pre-calc is the limit. So the limit part that we're going to do is the pre-calculus. And then finally, the derivative itself will be, not pre-calc, just regular calc. Scratch that, calculus. All right, so calc for calculus. And by calculus, of course, I mean calculus 1. You do a little bit of calc 2 in calc 1 because it builds on itself, but it's really not for calc 2, because by the time you get to calc 2, if you don't know how to take a basic derivative, you're in trouble. So let's just jump right into to the different parts here, and we'll start off with an example. And I'll show you how to do the f of x plus h minus f of x over h. So the algebra 2 part, and then we'll do the limit part, and then it'll build into the calc part. But basically the whole point of this is that you don't really need to go back and do the whole limit again to check your work. You can just do the derivative and check it. So this is primarily good for you if you are in pre-calculus. So let's look at an example. If I have, let's say I have a function, and it's x squared plus 1. Okay, let's do the algebra part first. So I want to do f of x plus h minus f of x over h. And I want to try to plug it in and simplify it as far as I can go. So the trick to the f plus x plus h part, would be that I'm gonna change this right here, and this and this are gonna stay the same. So f of x plus h would look something like this. F of x plus h. So the new x, right? It was f of x. Now it's f of x plus h. So this x becomes an x plus h. I need to wrap it in parentheses though, because I'm going to take it and square it and then add 1 to it. Because the 2 and the 1, the square and the plus 1, those stay the same. The x changed to an x plus h. So that's our f of x plus h function. And I'll write that here. We've got x plus h quantity squared, which, by the way, I might as well go ahead and do this. X plus h quantity squared is the same thing as x plus h times x plus h. You cannot distribute the square. You're going to miss out on the middle terms. If you try to distribute the square, you'll get it a little bit right, but not all the way right. And in math, it has to be all the way right. So x plus h times x plus h, because if I square it, then that's the same thing as saying, hey, I want to have this thing multiplied by itself. All right, so I'm going to go ahead and copy that over into my f of x plus h thing. So you know what, let's go ahead and FOIL this out. First times the first, x squared, outer times the outer, xh, inner times the inner, plus hx, and then last times the last, h squared, and then of course that plus 1 has to hang around. He's going to just hang around us a little bit here today. So then let's go ahead and put that in here. X squared plus xh plus, I'm going to switch this to an xh. hx and xh is the same thing. Plus h squared plus 1 minus the function. So minus the function. I have to be careful though, because if I minus a whole function, it's like taking the opposite of each thing that's inside of it. So it wouldn't just be minus x squared plus 1, it's going to be minus the whole thing. So notice I'm leaving out the h on the bottom. I don't really care about the h right now. I'm just trying to simplify the top. There's nothing to do on the bottom. It's just an h. So once I can get all the top stuff together, then I might be able to cancel out that h. So I've got two xh's here. One here and one here. 1 plus 1 is 2. There's two xh's altogether. Plus h squared plus 1 minus x squared minus 1 after I distribute that. All right, so then you should have things that cancel, right? You should have things that cancel. If you notice, the x squared minus x squared, that's 0. And then 1 minus 1 is 0. So I'm just left with the 2xh plus h squared. Oh, and don't forget, it was over h. Over h. Okay, so, oh, wait, hold on. One more thing, I almost forgot. There's a little bit further we can go. H, I can take an h out on the top. 2x plus h, boom, over h, cancels. Okay, now we're done. Whew. So, 2x plus h, final answer if you're in Algebra 2. If you're in pre-calc, then you can go a little further, because now in pre-calc, they're going to have you take the derivative, the limit as h approaches 0 of 2x plus h. Well, if you have a limit and you want to try to plug it in, you just plug it in unless there's a problem. Now, originally there was a problem. There's an h on the bottom. If I plug in a 0 for h when there's an h on the bottom, that's a problem. But I got the h to cancel. It's gone. I can just plug in h. So it's 2x plus 0, which is just 2x. That's it, right? So the actual limit part is pretty easy. The algebra part took forever, yeah, but the limit itself was pretty easy. Now, here's the crux of why I wanted to do this video. That limit took forever, right? Most of it was algebra, got down, and then we're in the red. We do limit of h approaching 0. We can just plug it in because I've fully simplified all the algebra stuff I had to do, and I got 2x as my answer. So that's the limit. But well, all you have to do to check your limit in pre-calc is to just kind of move ahead a little bit, because guess what? Derivatives are actually really easy. Like just the basic ones, the basic derivatives, the whole concept is actually very easy. My original function, if you look here, is f of x equals x squared plus 1. All right, so check this out. X squared plus 1. I want to take the derivative. This means take the derivative. It's sort of like how you have a math function. It's like, hey, multiply these two numbers. Hey, times these two numbers. D over dx means, hey, take the derivative of these things. So it's sort of like an operator almost, meaning like it tells you to do something, right? Times tells you to multiply the two numbers that the times symbol is in between, right? Same thing for plus and minus and divide. So in order to take the derivative, here's what you do. First step, I'm going to take the power and multiply by it. I'm going to take the power and multiply it. So that means I'm going to write 2x squared plus 1. All right, you're going to multiply by whatever the power is. Right, and this goes for all the power. So if you have more than one x, you do this for each individual x. All right, so then I'm going to subtract 1 from the power. Subtract 1 from the power. That's pretty easy, right? 2 minus 1 is 1, so that's just 2x to the first power. All right, and then the last thing is that all constants, I almost spelled constants wrong. All constants go away. They all go away. So the answer is just 2x, and look at that. It's exactly the same as that. Okay, so this video is more about taking the derivative than it is about taking the limit. So let's say we have, and let's do maybe 2 more examples so you can just see how the derivative works. So let's say we want to take the limit as h approaches 0 of, well, you know what? I don't even need to write that. I'll just scratch all that. Let's just scratch all that. Just get straight into the derivative. Let's say I have a function, and it's x cubed plus 2x plus 3. Okay, so step 1, take the power and multiply by it. Okay, so actually there's 2 different powers of x in this example. So I'm going to multiply by the 3 and multiply by the 1. Well, in this case, that's not going to do anything. And there's no power for the 3, so 3 is not to a power. Well, the x isn't to a power in the 3, is what I should say. So step 1, then subtract 1 from the power. So subtract 1, subtract 1. This is going to be 3x squared plus 2, right? 1 times 2. X to the 0 power plus 3. And then all constants go away. Okay, so actually, check this out. Anything to the 0 power is equal to 1. No matter what x is, anything to the 0 power is 1. So this is just 2 times 1, which is 2. Okay, so the 2 doesn't go away. The 2 was the answer. Remember, constants go to 0, but that 2 was not a constant. It came from 2x. So the answer to the derivative would be dx of all that, 3x squared plus 2. All right, let's do one more, and then we'll call it quits here. So let's say we have, and I'm doing all polynomial functions. So if you're in calculus and you've done other functions besides polynomials, you know what I'm talking about. But when you're not doing polynomial functions, just x to a power, there's different rules for that as far as derivatives. So that's when it starts to get a little more complicated. But let's do a little bit of everything. Let's say 2x to the 4th plus 3x to the 3rd plus 4x squared plus 5x plus 6. So just start at 2 and it went up to 6. Okay, let's do this. So step 1, I'm not even going to go up to the steps. We'll just see, and actually pause this video if you want to try this out and take this derivative and see if you get the same thing. Okay, so step 1, multiply by the power. 4 times 2x to the 4 plus 3 times 3x to the 3 plus 2 times 4x squared plus 1, right, that's a 1, times 5x1 plus 6. Next step, I'm going to subtract 1 from the power, so that's 8. X to the 3rd plus 9x squared plus 8x to the 1st plus 5x to the 0 plus 6. All right, and then last step, all constants go away. All right, so we're going to clean this up a little bit more for our final answer here, make it look nice and pretty. For some reason, math teachers, mathematicians, all math people seem to like pretty answers for whatever reason. That's 5 times 1, not 5 times 0, don't get it twisted. It's just plus 5. So the way you can remember that rule actually is that 5x, any constant, right? So this thing right here, any constant times x is just going to have the x go away, and it's just a constant, right? You can remember it that way if you want. But that's the answer. So I hope you got that right. If you did, good job. Give yourself a pat on the back, courtesy of Mr. Kyle at Myers Mathematics. And also, go ahead and give this video a like if it was helpful. Subscribe to my channel if you want to see more videos like this. Comment below if you want to see a video on any math topic, ranging from pre-algebra to Calc 3 and everywhere in between. All right, whether it's a middle school, high school, or college level math class, all right, or even just SAT or things like that. And then also, if you haven't already, go ahead and go to my website, myersmathematics.com. I have a free guide on there called The 5 Math Mistakes Everyone Makes and How to Avoid Them. I want you to go there, grab that free guide. It's yours for the taking. You just get it from my website, myersmathematics.com. And this has been Mr. Kyle. Hope you have a blessed day.